Now, let's talk about the normal distribution. The normal distribution, statisticians, they all agree that any sample which is greater than 30 is always to be normally distributed. Let's see the normal distribution curve. Our curve, it looks like a bell shape. So I have it this way. A bell curved shape with the mean at the center of it. I can write, if I have a variable x to be normally distributed, I can write it this way. X is normally distributed with the mean and the standard deviation squared. So always we have to know the mean and we know always to know sigma. Let's talk about the properties of the normal distribution curve. The first thing, the area under the curve represents the probability, equal to the probability. And since the probability always equal to 1, so the area is equal always to 1 or 100%, which is the probability. The second thing that we have to know, that the normal distribution curve is always symmetrical, So, which means that this area on the left-hand side of the mean represents 50%, or the probability represents 0.5. I have the mean at the middle and I have the standard deviation, which takes me away from the mean. These are the main characteristics that you have always to understand about the normally distributed curve. For normal distribution, there are always two types of questions. The first type of question, when the x value is given, and we need to find out the probability. And we need probability. In this case, I need to find out the area. Find out the area. The second case, when the area is given or the probability is given, and we need to find x. In this case, we need to find out x. Through the example, I'll explain to you how I'll be finding a given probability, or through a probability, we will find the value of x. Let's have this example. The time in seconds needed for a student to solve a mathematics equation is modeled by the variable x. You are given that x is normally distributed with mean equal to 25 and the standard deviation equal to 4, because this is 4 squared. We need to find, for part A, the probability that x is less than 23. Always, let's draw our normal distribution curve. This is for part A. This is my normal distribution curve. I have the mean here to be 25 seconds, and I have the standard deviation to be 4 seconds. I want the probability of x less than 23. So I'll add the 23 in here. And I want to find out the probability that x is less than the 23. This probability is unknown. So now to find out the probability x is less than 23, I need to use my graphical display calculator. I go to menu, I go to statistics, and I go to dist, which means distribution. I go to norm, and I go to NCD. To find unknown probability, I go to NCD. I press var because it's a variable. Now, for the NCD, the lower bound in this case is always negative infinity. So it's a negative times a very big number. So I have to add it on my graphical display calculator. So the lower bound would be negative 9 times 10 to the power of 99. Next. The upper bound in my area is the 23. Sigma is equal to 4 and mu is equal to 25. And I just execute having my probability to be 0.309 rounded to 3 significant figures. So this is 0.309 rounded to 3 significant figures. Let's do part B now. This is part B. 10% of students took more than m seconds. We need to find the value of m. So we have to draw again our normal distribution curve. I have it this way. Let me just erase it because this is my normal distribution curve. Now, I have the mean to be 25 and sigma equals to 4 seconds. And I have that 10% of students took more than 8 seconds. Since 10% took more than m seconds, I have the value of m to be in here. And the area under the curve equals 10%, which is equal to 10 over 100, 0.1. In this case, I have a given probability but unknown value of x, which is in our case m. To find m, I use also my graphical display calculator. I go exit. Since I have the area given and the value unknown, I go to normal distribution, but in this case, I use env, which is inverse norm. I go, my data is a variable, my tail, I see my tail is on the right, so the tail is on the right, the area is equal to 0.1, and my standard deviation is 4, and the mean is equal to 25, and just execute having the value of m to be 30.1 seconds. So the value of m is equal to 30.1 seconds. I hope it's clear. This is always how we do the normal distribution. You always have to use your graphical display calculator to solve any normal distribution problems.